Now we'll see a question based on P and N type semiconductor. How we will identify that it is P type, it is N type semiconductor. So classify each as being P type or N type semiconductor. First question is germanium doped with indium, and second case boron doped with silicon. So in this case you have to know the group number, in which group of periodic table they falls. So first thing is to know the group number. So germanium. So germanium is of which group? So we have learned the sequence Bal Jayanti, group 13, Bal Jayanti, boron, aluminium, gallium, indium, thallium. This one is of group 13. Group 14 is semiconductor, Kasi Jason pub, carbon family. Group 15 is nitrogen family, Napasabi. Now focus on the elements. Germanium doped with indium. So germanium is of group 14, that is a semiconductor, is doped with indium. Going back, going at the back. So germanium is going at the back. So if germanium is doped with indium, which type? So here let's see the theory. So germanium is group 14 element and indium is group 13 element. Hence electron deficient holes is created, and therefore it is p type. So just keep in mind, so if group 14 elements are doped with group 13 element, then the holes will be created and they are called p type. Positive holes will be created and they are called p type, because germanium have how many electron? Plus 4. Plus 4. If they loses electron, how many electrons they can lose? Plus 4. And indium metal can lose how many electron? Plus 3. So from plus 4 it changes to plus 3. Therefore positive holes are created by going at the back from plus 4 to plus 3. Means keep in mind, if group 14 is doped with group 13 elements, then p types, they are called p type semiconductors. P type. Second case you can understand more easily. Boron doped with silicon. Now see, where is boron? Where is boron? Group 13 boron is doped with silicon, group 14. So group 13 elements, first we have seen group 14 was doped with group 13. Valency decreases. So if the valency decreases from plus 4 it goes to plus 3, it will be plus p type. If valency increases, it will be n type. So from plus 3, if boron loses plus 3 electron in group 13, it loses one more electron in silicon. So conduction is due to the release of electron, liberation of electron, and here conduction is due to the valence, to the positive ion. Therefore from plus 3 it changes to plus 4. By losing one electron it changes to plus 4. So therefore it is n type. It is n type semiconductor, n type. So if group 13 doped with group 14, n type. If group 14 doped with group 13, that will be p type. Getting reversed, p type coming to the forward from 13 to 14, that will be n type. Again I am explaining that plus 3 to plus 4, what has happened? From plus 3 means 3 electron lost by the boron, but plus 4 by silicon means 4 electron has been lost. So 3 electron, now 4. What is the difference? 1. So that 1 electron, more 1 electron is lost. So the conduction is due to the loss of electron or the movement of electron from 13 to 14. Therefore that creates n type, conduction due to electron. But in case of p type, from positive plus 4 it changes to plus 3. So positive ions are decreasing. Positive ions are decreasing. So therefore conduction is due to the positive ion. Therefore it is called p type. Simple logic, simple trick. If they are moving forward, n type. If they are going back, that will be p type. So that is the first question. It is made clear here. Boron is group 13 element and silicon is group 14 element. There will be free electron, hence it is n type. Free electron means 13 plus 3, 14 plus 4. So from plus 3 to plus 4, one more electron is lost. So therefore it will be the free electron, hence it is n type. Now coming to the another question of NCERT, that is question number 23. Here even in short I have just explained it. Group germanium plus 4, indium plus 3. Electron less, so holes due to it. Electron less from plus 4 to plus 3, less electron available. So therefore positive, so holes due to it. Electron less, so holes due to it. From boron plus 3 to silicon plus 4, electron more. Free, so free electron present. Leave it, but focus on this, which what I have explained. From plus 13 to plus 14, n type. From plus 14 to plus 13, going back, that will be the p type. Now another question based on it is group question number 23 inside question of NCERT. A group 14 element is to be converted into n type semiconductor by doping it with a suitable impurity. To which group should this impurity belong? Now question asks that we have to convert group 14 element to n type. Now you say that with which group will dope group 14 element, group 13 or group 15 to have the n type conduction due to free electrons. So I have already said to go to the n type you have to move further. Move further means if it is group 13 we go to group 14, if group 14 we go to group 15 to get n type. Now the answer, so there where we'll go with the 15. Now n type semiconductor means conduction due to presence of excess of negatively charged electrons. So what the meaning of n type? N type semiconductor means conduction due to presence of excess of negatively charged electrons. N type. Hence to convert group 14 elements into n type semiconductor, it should be doped with group 15 element. To move further, to have the more electrons, free electrons, so group 14 will be doped with group 15. So therefore n types of holes, n type of semiconductor will be obtained. So two questions we have seen. Now one more question we'll see. See this question number 18 of NCERT. Non-stoichiometric cuprous oxide, formula is Cu2O, can be prepared in laboratory. In this oxide, copper to oxygen ratio is slightly less than 2:1. Means copper is less and oxygen is 1. Can you account for the fact that this substance is a p-type semiconductor? So they are saying that is it p-type semiconductor? So we'll focus here whether it is p-type or n-type. So the ratio less than 2:1 in Cu2O. So copper, we can give the oxidation number plus 2 on 2 copper and oxygen minus 2. So 1 oxygen minus 2 and 2 copper plus 2 means 1 copper having plus, single plus. So the ratio less than 2:1 show that some cuprous Cu plus ions have been replaced by cupric ions. Means Cu plus is replaced by Cu2 plus ion. That can only happen when there is increase in positive. We have already seen if it is group 14 doped with 15, so from plus 4 its oxidation number increases to plus 5. So from plus 4 it changes to plus 5. So if the copper is in oxidation state Cu plus, and if it changes to Cu2 plus, then only that can happen. So therefore what we are saying that in cuprous oxide Cu2O, the oxidation number of copper is plus, Cu plus, have been replaced by cupric Cu2 plus ion, then only that can happen. To maintain electrical neutrality, every 2 Cu plus ion will be replaced by 1 Cu2 plus ion, thereby creating a hole. So every Cu plus ion will be replaced by 1 Cu2 plus ion, thereby creating a hole. So if Cu plus is replaced by Cu2 plus, it means more positives are created, hence creating a hole there. So if the hole is created, as conduction will be due to presence of these positive holes, Hence, it is a p-type semiconductor. So, conduction due to positive holes. Positive holes, how positive holes? Because one C, 2 Cu plus is replaced by 1 Cu2 plus. So, positive holes is created, na? Cu2 plus where 2? Cu2 plus where 2 and is replaced by only one Cu2 plus. So, one is still one Cu plus column or the place will be vacant. So, that is the positive charge. So, conduction is due to positive only, na? So, therefore, it is called